Hey there, and welcome. Today, we're going to build ourselves a really powerful mathematical toolbox. And what's it for? Well, it's going to help you master the art of comparison, which is something, believe it or not, you're already doing every single day. So let's pop open that toolbox and get started. So here's our game plan. First, we'll get a handle on what comparison even is. Then we'll grab our first tool for the job, the ratio. We're going to sharpen that tool up by learning how to simplify, give it a serious power upgrade with something called proportions, and then finally we'll put our whole new toolbox to the test on a real-world problem. Okay, first things first. Let's start with the absolute basics. What do we even mean when we say comparison? Forget about math for just a second. This is something your brain does automatically all day long. I mean, think about it. Right now, in your classroom, are there more boys or girls? In your pencil case, more pens or pencils? See? Your brain is this natural comparison machine, just constantly sizing things up against each other. It's something we do constantly, without even thinking about it. But math gives us a really precise, a universal language to talk about these comparisons. And that language all starts with one simple but super powerful idea, the ratio. So what is a ratio at its core? It's just a way of comparing two numbers by using division. So, for example, if a class has 10 boys and 15 girls, we can express the ratio of boys to girls as 10 to 15. Simple as that. And you can write this down in a few different ways. You can literally use the word 2, like 10 to 15. You can write it as a fraction, 10 over 15. Or, and this is the one you're going to see most often, you can use a colon. All three mean the exact same thing. All right, we've got our first tool from the toolbox, the ratio. But you know, like any good tool, there are a few rules you've got to know to use it right. So let's check them out. Now these rules are really just about common sense. You have to compare things of the same kind. Apples to apples, not apples to hours. And they need to be in the same units. Also, since a ratio is basically a fraction, the units cancel out, so your final answer won't have any units. And this one is crucial. Order matters. 10 boys to 15 girls is totally different from 15 girls to 10 boys. And finally, you always want to make it as simple as possible. So how do we simplify? Well, you just have to find the biggest number that can divide evenly into both parts of your ratio. It's called the highest common factor, or HCF. For 18 and 24, what's the biggest number that goes into both? It's 6. So we divide both sides by 6, and we get our new beautifully simple ratio, 3 to 4. And this is exactly why we do it. I mean, look at them side by side. Which one is easier to understand in a split second? 18 to 24 or 3 to 4? The relationship is exactly the same, but the simple version makes it crystal clear. Okay, so we can make a ratio and we can simplify it. Now it's time to sharpen our tool a little bit more. How can we use this skill to figure out which of two different ratios is actually bigger? Let's try a little puzzle. Which one's greater? A ratio of 2 to 3 or a ratio of 3 to 4? It's not so obvious just by looking at them, is it? But don't worry, there's a really clean way to figure this out. Here's the secret. You turn them into fractions that have the same number on the bottom, the same denominator. So 2 to 3 becomes the fraction 2/3, and 3 to 4 becomes 3/4. Now what's a common number for 3 and 4? 12. So 2/3 becomes 8/12, and 3/4 becomes 9/12. And now the comparison is a piece of cake. We're just comparing 8/12 to 9/12. Well, 9 is obviously bigger than 8, so that means the ratio 3 to 4 is greater than 2 to 3. Problem solved. Okay, I think you're ready for the power upgrade. What happens when you have two ratios that look different but are actually equal? Well, that special relationship has a name, and it's a real game changer. It's called a proportion. A proportion is really just a statement saying, hey, these two ratios are equal. We write it out like this. A is to B as C is to D. Now the two numbers on the very outside, A and D, we call those the extremes. And the two on the inside, B and C, those are the means. You're going to want to remember those terms. Because here comes the magic trick. This is so cool. In any true proportion, if you multiply the extremes, the two outside numbers, you will get the exact same answer as when you multiply the means, the two inside numbers. This little rule is the key to solving all kinds of problems. Don't believe me? Let's prove it. Let's ask, are 2 to 3 and 4 to 6 in proportion? Okay, let's test our magic property. The extremes are 2 and 6. Multiply them together, you get 12. The means are 3 and 4. Multiply them together, you get 12. Since 12 equals 12, yep, we just proved they are absolutely in proportion. Okay, our toolbox is officially locked and loaded. We've got our ratio tool, we've sharpened it up with simplifying, and we've given it that awesome proportion power-up. It's time to solve a real-world puzzle. Here we go, a classic scenario. You're baking, right? The recipe says you need 300 grams of flour to make 12 cupcakes. But what if you want to make 30 cupcakes for a party? How much flour do you need? This is a perfect job for our new proportion tool. So, the very first step is to set up our two equal ratios. The absolute key here is to be consistent. On the left side, we put cupcakes on top and grams of flour on the bottom. So on the right side, we have to do the exact same thing. Cupcakes on top, grams on the bottom. That unknown amount of flour, that's our x. And now we get to use that magic property. We cross-multiply. So 12 times x has to equal 300 times 30. A quick calculation tells us that 12x equals 9,000. To get x all by itself, we just divide 9,000 by 12, and that gives us our answer. And there it is, 750 grams. We just use proportions to scale a recipe perfectly. See? This isn't just math you do in a classroom. It's kitchen math, it's workshop math, it's everyday math. So let's end with this one last thought to bring it all together. A ratio is just a single comparison, right? Like boys to girls. But a proportion is the bridge that connects two equal comparisons. And understanding that difference, that a proportion shows equality, that's the key. It's what lets us take something we know, like a recipe for 12 cupcakes, and use it to figure out something we don't. And that is a seriously powerful tool to have in your toolbox.